Today we're going to be working on exponential equations and how to solve them with a logarithm now. So in a previous video, we talked about how to solve these with your elementary cases, so trying to get your bases to match. However, if it's not possible to get your bases to match, right, 5 and 20, right? Well, yes, 20 has a 5 in it, so 4 times 5, right? There's just not enough fives in order to make the 20 special, to have an exact base to match 5. So in that case, we're going to have to use your logarithm. The reason why we can use a logarithm is that we can use the inverse property. Exponentials and logs are inverses of one another, meaning that one does something and the other undoes it. So when their bases match, we can go ahead and cancel. And we saw that in a previous video as well, where we were converting from a logarithm into an exponential. So this is where we can actually convert the other way. Now there's two ways to do it. One way is the swoop method, and I'll see if I can write above here. So if we have x to the y is equal to z, right? One way is called the swoop method, where you start on your base, you come up and around, and you land on your exponent. So the order in which you swoop is the order in which you write it. So you write 1, 2, 3. Now, the only thing that I don't like about the swoop method is actually this part, because a lot of us might just write x, z is equal to y. Well, that's actually not quite the case, because we need to make it into a logarithm. So we first must write the word log. Then we can go ahead and give the base of x. Your base of x for your logarithm needs to match the base of your exponential. Then we can go ahead and write the rest. We have log base x of z is equal to y. So you notice that when you write a logarithm, you have to write the word log. Now the other method is if we take x to the y is equal to z. A different method, instead of the swoop, is to actually use the inverse property. So I have to write the word log and match the base. So now this makes it into a logarithm with the same exact base. Now what you do to the one side, you do to the other side. So again, you write the word log with the exact same base. And what this allows us to do is that it actually cancels out on one side, allows your y to drop. So now you have y is equal to log base x of z. And you'll notice that you come up with the same exact answer as the other one. So it's up to you on how you want to evaluate these. So I'll kind of do every other one. So I'll probably start off with the swoop method, and then I'll show you the inverse method. And then I'll probably hopefully strictly stick to the inverse. So from here, if we're asked to solve for x being in the exponent, and 5 and 20, there's no way to make the 20 into a 5. We're going to be using that inverse property. So we can use your swoop method if we prefer. So again, we have to first write the word log. And we have log base, and we have the base of 5. Again, these have to match. So we first write the 5. Then the next number we write is 20 is equal to 2x. Now let's go ahead and divide everything by 2. So x is equal to log base 5 of 20 divided by 2. Now 20 divided by 2, it's not just we can make this 10 and then we have log base 5 of 10. Right now, this actually, log base 5 of 20 is going to be a number. We're going to take that number and then divide it by 2. Now for me, I'm going to say that we are done here. This is your exact answer. If you wanted to punch it into a calculator, you could do one of two things. You can, well, if you have a calculator, some calculators, we have the logarithm that's already built in. So the logarithm that's found on the left-hand side next to your 7 does not allow you to change your base. It's actually a common log, meaning it has a base of 10 strictly. So in other words, we have to go ahead and find where we can do a change of base. So by going to math and then going all the way down till you locate log base, you'll notice that we can actually go ahead and put in a logarithm of a different base, 5 of 20. We're going to divide this number by 2. Now you can also, if you don't have a calculator that can do a logarithm with a different base, we can use the change of base formula, which just allows us to use a common log, so matching your own bases. We have the 20 above divided by the log of 5. Now 5 used to be our old base, and 20 used to be the number that we were evaluating, but now we are doing a combination. So now we're using a common log, so that we're matching your bases, and we're just dividing the old base. Now we're going to take this number and we're dividing it by 2. And yet again, you'll notice that it comes up with the exact number here. So about 0.90, I think it was like 7. This would be your approximated answer, your estimated answer. Let's try it again with 14. So this time I'm not going to use the swoop method. Instead, I'm just going to match my base. So I'm going to have to first write the word log. Now I have a base here of my exponential of 12. So I need my base of my logarithm to match. What I do to one side, I do to the other. And it allows me to cancel and my exponent drops. So we have 2x minus 8 is equal to log base 12 of 15. Now again, that is a number. So those cannot come apart. I even might put this into parentheses. Now we solve for your x, your variable, as you would a linear. So the first thing we could do is add the 8 to the other side. And again, you cannot add 8 to 15 because this, again, is a number. These do not come apart. Then we can go ahead and divide by 2. So you have x is equal to log base 12 of 15 plus 8. And the whole thing is divided by 2. Or you can multiply it by 1/2. Let's try it again over here. So we have 12x minus 1 is equal to 20 raised to 2. Interesting, all right? So if we wanted, we could reduce or simplify this a little bit further and actually get it in its expanded form of 400. That's probably what I would do before I get started, is 12 is equal to 400. So now again, we can use your swoop method or just by writing your log of the equal base. So we first have to write log base 12 of 400 is equal to x minus 1. Add 1 to the other side. So x is equal to log base 12 of 400 plus 1. And again, it's not 401 and then your log base. This is your number. Let's take a look at just a few more. We'll just do maybe 2 more, 3 more, maybe 1 more row. All right, now before we go ahead and evaluate one like this, we want to make sure that before we take any sort of logarithm that our logarithm is all alone, or your exponential term is all alone on one side. So our exponential term being this e raised to this 2x minus 3, we want this to be alone. So before that, we need to add the 4 to the other side. So adding 4 to the other side, we get 82. Then divide both sides by 3. And we'll keep it as a fraction. Well, we want an exact solution. So now that you have your exponential all alone to one side, we want to use either the swoop method or matching the exponential base. So for us, we haven't talked about e here yet on this page. E has an inverse of ln. So instead of writing log base e, we're actually going to write log natural log, because natural log already has a base of e. So we can just write ln. So we're going to write your ln of both sides. Again, this has a hidden base of e, so it allows us to cancel and drop this exponent. So we have 2x minus 3 is equal to ln natural log of 82 over 3. So now we can solve for your exponent, or sorry, solve for your x value. So you can say 2x is equal to ln of 82 over 3 plus 3. X is equal to ln of 82 over 3 plus 3 all over 2. All right, let's try it again in your next row. So let's add 4 to both sides. 6e to the 10x minus 8 is equal to 38. Divide everything here by 6. E to the 10x minus 8. So 38 divided by 6. If we wanted to reduce it as a fraction, we could do it here to make 19 over 3 as a reduced fraction. Now again, we can write your logarithm, or you can go ahead and swoop if you prefer. If you do swoop, we have to write ln of e or just ln. I'll just keep my e here so you can kind of see where it went. Of 19 over 3 is equal to 10x minus 8. So go ahead and solving for your x value here. So you have ln of 19 over 3 plus 8 is equal to 10x. And the last thing, we are dividing by 10. Now, same sort of idea, but now instead of a natural log, we have a base here of your exponent of 10. So we first want to work towards getting this value alone and on one side. So let's go ahead and add 8 to the other side. So you have 8 times 10, 7x minus 6. And no, you cannot make this just an 80 to the 7x minus 6. This will come out to be a very specific number based on whatever x we solve for. So we go ahead and add 8 to the other side. Divide by 8 here. So we get 10 to the 7x. I don't know why I'm writing so big. 10 to the 7x minus 6 is equal to, let's see, this being divided by 8, I don't believe reduces any further. No, 67 over 8. So we have here a base of 10. So whether you want to do the swoop method or the logarithm inverse property, when we go ahead and write your log base, your logarithms, not your natural logs. Well, if your natural logs have a base of e, a regular logarithm, so a common log, already has a base of 10. This is what your calculator does when you hit the logarithm button on the left-hand side, kind of next to that 7. It already has a base of 10. This is called your common log. So instead of writing our base of 10, it's a little redundant. I'm going to write mine just so you see where it goes. But this will allow us to cancel on one side, and you have the log base 10 on the other side. It drops, so we have 7x minus 6 is equal to log of 67 over 8. And again, just solving as you normally would. You have 7x minus 6 is equal to log of 67 over 8. So then add 6 to the other side. Divide by 7. You'll notice that I'm not writing the log base 10 anymore. You do not have to if it's a base of 10 that your exponent is in. Same thing over here. You didn't have to write the e anymore because ln has a base of e. The other ones, they do matter, like this 12 over here. Where else do we have a number? So this 5, right? Because these are not specific logarithms. And I'll show you how to figure out your ln over here or find it on your calculator. Your ln is right next to the 4 and the 7, right underneath your logarithm. So you'll notice it right there. And I'll show the answer key because I think this video is just about complete. So hopefully you pause the video and you try out the remaining 6.